guys. So today in this video we will discuss about how to select MOSFET based on their current ratings. So let's consider an example where let's suppose DC-DC converter you are working on, and you are required to have something around 60 amps or 50 amps of MOSFET, which can provide continuous 50 amps. So in this case, how you will select your MOSFET? So what should be the current rating of the MOSFET? So your steady state operation is 50 amps, so you should select 50 amps MOSFET, or you should go a little bit of higher amps, let's say 60 or 70 amps. So how should we decide the amp value of MOSFET? So here I am considering 50 amps MOSFET, what we are seeing on the screen. So just for an example, I'm choosing Infineon 50 amps MOSFET. This is a T2 pack SMD package MOSFET. So the idea is simple. You just have to go to characteristics where ID current is given. So as you can see that here ID, that is drain current, is given with respect to temperature. So this is the only deciding factor of your MOSFET, that how much current it should provide based on your application. So here you can see that we require 50 amps and this MOSFET is giving 50 amps. So yeah, that's okay, and this can also provide 50 amps till 125 amps, so that should not create any problem. But here we have to note that this 125 degrees Celsius is the junction temperature. So other than this junction temperature, if in case you are working in automotive industry, you might have seen that there is an ambient temperature, so that is something around 60 to 75 degrees Celsius. So worst case, let's consider around 75 degrees Celsius ambient. Then the junction temperature from your current is remaining 125 subtracted 75, that is around 50 degrees Celsius. So if your operating current is such that it crosses the 50 degrees Celsius, that means total junction current will cross 125 degrees Celsius. If in case your junction temperature is let's say 70 degrees Celsius and your ambient is also 75, then your net junction temperature will be 145 degrees Celsius. That means around you are operating somewhere here. So this MOSFET cannot provide current greater than 40 amps, and but you require to operate at 50 amps. So based on this type of calculations, you have to decide that whether this MOSFET can provide 50 amps at 140 degrees Celsius or not. So if you require let's say 50 amps for steady state operation, and like throughout the temperature, junction temperature, let's up to 150 degrees Celsius with no problem. So you have to choose MOSFET such that 50 amps should come here and then start derating. So you can also see that here power dissipation, maximum power dissipation is up to 25 degrees Celsius. So after 25 degrees Celsius it starts derating, so it cannot provide full power. So you have to choose a MOSFET in such a way that it provides your required current at required temperature by seeing these characteristics, and that too fulfills the power requirement by seeing these characteristics at that particular temperature. So two things are important: one is temperature and one is your required current. After the required current is fulfilled at particular temperature, you can go with derating factor. And also while going with derating factor, you should be careful that even in derating also, is it fulfilling your requirement or not. So you have to consider derating also. For example, there is something around 175, let's say 160 160 degrees Celsius. This is providing 25, but you require 30 amps. So you have to choose MOSFET such that it provides 30 amps or more at 160 degrees Celsius. So this is the basic idea. There is nothing very like difficult thing or very complicated thing. Just see the characteristics and and just see the power dissipation characteristics and identify that that characteristics is matching your requirement or not. And the other point you have to note is that here VGS is 10 volt. That means this MOSFET is turned on sufficiently so that it provides full load current. So if you are operating at 12 volt or 13 volt, then it's still you can refer this characteristics. Otherwise you can also check VGS characteristics. Sometimes it's also given VGS, for example, this VGS characteristics with respect to temperature. So yeah, this is it for this video.